In machine learning, we often use k-means to group our data. But how do you mathematically prove your clusters are actually good? You can't just eyeball it when you have thousands of dimensions. The silhouette score gives us a value between -1 and +1 to tell us if a point is in the right place. Today, we're going to calculate it from scratch using a 2D numerical example. To understand this formula, we need to define two variables, A and B. A represents cohesion. How close is this point to its own neighbors? B represents separation. How far is it from the next closest cluster? In an ideal world, we want A to be very small and B to be very large. Let's take a coordinate plane. We have cluster A and cluster B. We want to find the silhouette score for this specific point, P1, located at 1, 2. First, we calculate A. This is the average distance to all other points in the same cluster. Since there's only one other point, P2, we use the distance formula. The distance between 1, 2 and 2, 2 is exactly 1. Now for B, we need the average distance from P1 to every point in the nearest neighboring cluster. The distance to P3 at 5, 5 is 5 units. The distance to P4 at 6, 5 is roughly 5.83 units. Average them out and we get 5.41. Now we plug these into our silhouette formula. 5.41 minus 1 divided by the maximum of those two numbers, which is 5.41. We get 0.815. Because this is close to +1, we can confidently say this point is well clustered. If this number were near 0, it would mean the point is sitting right on the border of both clusters. If it were negative, it means the point is actually closer to cluster B than its own group. By averaging the silhouette score of every single point, we get a global silhouette score for the entire model. That is how you validate your clustering logic from the ground up. Deconstructing these metrics from scratch is the best way to understand what's happening under the hood of your Python libraries. If you found this numerical walkthrough helpful, hit the like button and I'll see you in the next one.